We're here at the MEBA school and we'll be demonstrating today a Toshiba brand overload relay. And first we're going to show you the different components of the overload relay, and then we have a tester hooked up to it that will provide us our test current, and we'll get to see our relay in operation. So first I'd like to talk about the power section, and those are these three phases here. On the bottom connection would be connected to the contactor, and the lower section, this unit's turned upside down, the lower section is connected out to the motor leads. The main motor current, 100% of the motor current flows through this relay, and as you can see we have big fat wires connected to the outside terminals, but inside the heater we see that we have this nichrome wire that's wrapped around an insulator, which is wrapped around a bimetallic element. And the bimetallic element is one that has two different metals bonded together, and these two metals are selected because they have a different coefficient of thermal expansion. And what happens is as they heat, one side of it will grow faster than the other side, and this will cause it to deflect, and you'll see that quite evidently in just a few moments. When I've removed the linkage for ease of demonstration, but when the linkage shifts over in this direction, it'll affect this bar here, which operates the trip circuit in our control section. Now it's very important that you remember that the power section that has the current flowing through the motor, the 480 volts or the 240 volts or whatever your motor voltage is completely independent from the control section, which would have your 120 control power, your 24 volt control power, whatever you're using. And in the control section we have one set of normally closed contacts here. It's a single pole, single throw, and we have another completely independent set here, and this has a normally open contact. So what I've done is I've connected our decorative Fiesta party lights. We have a red light connected to our normally open contact and a green light connected to our normally closed contact. It's in the reset position right now. And so what I'd like to do now is install the linkage and run the test. Now we're only going to be heating one of as you can see, we've only hooked up to heat the middle element, so you'll see that, and it'll be a very graphic demonstration of the difference between, you'll get to see the one that moves and the others that stay in place. So without further ado, let's begin our test. And it should start heating, and as it starts heating you can see that it's starting to deflect. And it's pushing the linkage bar, which is up against the trip bar. And in just a few seconds here, there you go. And so the normally closed contact open, the normally open contact closed, and so we see what happens when we experience an overload condition. The other features that I'd like to show you are the reset button. Now the reset button isn't going to work right now because, as you can see, the bimetal is still bent over, so it's not allowing me to reset. And we have a push to trip feature here, and this allows us to trip the unit manually. And that concludes our demonstration.